The Quiet Genius, P.A.M. Dirac and the Unseen Universe. Beginnings. The making of a physicist. Paul Dirac was born into an environment of strictness mixed with intellectual stimulation. His father, a severe man, insisted on perfection in language, an early form of discipline that perhaps shaped Dirac's precise mathematical expressions. His mother, a librarian, introduced him to the world of books, fostering a lifelong love of learning. Despite familial challenges, including a tragic sibling loss, Dirac's passion for science ignited early. He excelled in electrical engineering before transitioning to the theoretical landscapes of Cambridge. Here, his genius began to unravel the complexities of the atomic world. The hardships faced by young Dirac shaped his silent, meticulous nature. These early experiences were not just obstacles, but stepping stones that led him to the halls of quantum theory. The Dirac equation revolutionizing physics. In 1928, Dirac introduced an equation that was set to revolutionize physics. The Dirac equation extended the realm of quantum mechanics to include the spin of electrons and predicted the existence of antimatter. This was not just a theoretical triumph, it was a doorway to new physics. The equation's elegance lay in its simplicity and power. It married relativity with quantum mechanics, two of the most groundbreaking scientific developments of the era. Dirac's work showed that every particle of matter has a corresponding antiparticle, which annihilates the matter particle, releasing energy in the form of gamma rays. This groundbreaking insight opened up vast new areas of research in high-energy physics and led to several experimental discoveries. Dirac's equation was a bold step into the unknown, one that earned him a Nobel Prize and eternal renown in the scientific community. The man behind the science. Paul Dirac was famously reticent, often preferring the company of equations over people. His silence was legendary. It was said he could convey the deepest of thoughts in the fewest of words. This characteristic made him an enigmatic figure, even among the giants of science. Dirac's personal life was as disciplined as his professional one. He married Margit Wigner, sister of physicist Eugene Wigner, in a union that brought stability and personal happiness. Despite his emotional reserve, his family life was content, marked by quiet affection rather than overt displays of emotion. Colleagues like Niels Bohr and Werner Heisenberg found Dirac's personality puzzling yet deeply intriguing. His interactions, though sparse, were impactful, influencing many budding physicists. Dirac's approach to science was one of deep thought and profound insight, often leading to breakthroughs that others could scarcely imagine. Despite his monumental contributions to physics, Dirac's fame never paralleled that of his contemporaries like Einstein or Bohr. His reluctance to engage with the public and the media contributed to this relative anonymity. However, within the scientific community, his legacy is profound and enduring. Dirac received numerous accolades throughout his career, including the Nobel Prize in Physics in 1933, which he shared with Erwin Schrödinger. He was also awarded the Order of Merit. His theories continue to influence modern physics, particularly in the realms of quantum mechanics and particle physics. Institutions have honored him by naming awards and lectures after him, and his works are a staple in physics curricula across the world. Dirac's insights into the fundamental nature of reality continue to inspire awe and admiration among scientists and academics. Dirac was not just a physicist, he was a philosopher of physics. He believed that beauty was integral to scientific truth, famously stating that a physical law must possess mathematical beauty. This philosophy guided his scientific endeavors, leading him to some of the most elegant theories in physics. His contemplative nature led him to profound insights about the universe. Dirac's musings on the role of mathematical beauty in physics and its implications for understanding the universe were ahead of their time and continue to influence philosophical debates in science. His philosophical approach was not only about understanding what is observable, but also about speculating on the nature of reality beyond empirical evidence. This blend of deep philosophy with cutting-edge science was one of Dirac's most unique contributions to the intellectual world. Beyond the Dirac equation and the prediction of antimatter, Dirac contributed several other significant theories to physics. His work on the quantum theory of radiation helped lay the foundations for quantum electrodynamics, a field that would later earn Richard Feynman, Julian Schwinger, and Itiro Tominaga the Nobel Prize. Dirac also introduced concepts like the Dirac delta function and the Dirac-Brocket notation, which have become essential tools in quantum mechanics. These mathematical tools provided new ways to describe and predict the behavior of quantum systems, profoundly impacting the study of physics. His theoretical explorations were not limited to known particles and phenomena. Dirac's speculative ideas often opened up new areas of research, demonstrating his ability to think beyond the existing scientific paradigms. Dirac's role in the development of quantum mechanics was pivotal. He was instrumental in refining and expanding the matrix mechanics of Heisenberg and the wave mechanics of Schrödinger, providing a comprehensive framework that could incorporate the principles of special relativity. His interactions with other quantum pioneers were of mutual respect, mixed with critical scrutiny. While he shared a deep intellectual bond with some like Heisenberg, he also engaged in rigorous debates with others, pushing the boundaries of the field. Dirac's contributions were crucial in moving quantum mechanics from a controversial theory to one of the most successful theories in the history of science. His work not only explained existing experimental data, but also predicted new phenomena that were later observed, solidifying the theory's empirical foundations. The prediction of antimatter was one of Dirac's most astonishing achievements. In 1932, Carl Anderson discovered the positron, the antiparticle of the electron, confirming Dirac's prediction and opening up new avenues in high-energy physics and cosmology. This discovery was not just a vindication of Dirac's theory, but also a fundamental shift in our understanding of the universe. It introduced the concept of symmetry in particle physics and led to the development of the Standard Model, which explains how the fundamental particles interact. Antimatter research has since influenced everything from cosmology to medicine, particularly in technologies like PET scans. This legacy of Dirac's theory is a testament to his profound impact on both theoretical physics and practical technology. Despite his monumental scientific contributions, Dirac was a reluctant celebrity. He shunned publicity and lived a life focused on research and reflection rather than fame. This aversion to the limelight was in stark contrast to some of his contemporaries, who were much more visible public figures. Dirac's shyness and reticence were so pronounced that they almost added to his mystique, making him a scientist's scientist. His focus was always directed towards the work, not the accolades. This disposition kept him out of the public eye but endeared him to those who valued profound intellectual achievement over fame. Dirac continued to work and teach well into his later years, remaining intellectually active until his death in 1984. He spent his final years in Florida, where he was a professor at Florida State University. His intellectual vigor remained undiminished as he continued to explore complex questions in physics. His death marked the end of an era in physics. The quiet genius who had revolutionized quantum mechanics and left an indelible mark on the fabric of science was gone. Reflections on his life and work continue to inspire awe and respect among physicists and scholars. Dirac's legacy is not just in the theories he developed, but also in the approach he exemplified, a relentless pursuit of truth, guided by beauty and simplicity. His work continues to be a beacon for those who venture into the depths of the quantum world. P.A.M. Dirac remains one of the towering figures of modern physics, his work foundational to much of our understanding of the quantum world. Yet his legacy transcends his scientific contributions. It lies equally in his unique approach to life and science, a blend of profound intellectual curiosity, philosophical depth, and personal integrity. Dirac's life reminds us that behind every scientific breakthrough is a human story, one of perseverance, insight, and sometimes profound silence. As we continue to explore the universe, we do well to remember the quiet genius of Paul Dirac, whose whispers continue to echo through the annals of science, urging us to look deeper and think clearer about the mysteries of the cosmos.